Section 9.3 is on polar and rectangular coordinates. There is a correlation between the location of a polar coordinate on the polar coordinate plane and the location of that same ordered pair on the rectangular coordinate plane. They're in the same place. But in order to find that same place, we have to do a conversion. There's a formula for converting between polar and rectangular coordinates. Remember that polar coordinates are of the form r comma theta. So in order to find the x-coordinate in rectangular coordinates, you would do the radius times the cosine of theta. And in order to find the y-coordinate, you would do the radius times the sine of theta. So how does this work? So in example 1a, we're going to rewrite the polar coordinate 5 pi over 3 in rectangular coordinates. Now, if you've already got your graphing calculator set up in degree mode, it might help to change pi over 3 to degrees. Remember, if you don't have it memorized, you can find out what pi over 3 is in degrees by multiplying by 180 over pi. The pi's cancel, and you're left with 180 over 3, which is 60 degrees. So the x-coordinate is going to be 5 times the cosine of 60, and the y-coordinate is 5 times the sine of 60. 5 times the cosine of 60 is 2.5, and 5 times the sine of 60 is around 4.33. So 2.5 comma 4.33 is in the same location that you would plot 5 pi over 3. Now I want you to think about this. Remember, 5 and 60 degrees means that the ordered pair would be in quadrant 1. And 2.5, 4.33 is also in quadrant 1. It doesn't matter if the radius is positive or negative. You're going to plug it in just the same. So in B, we're going to do negative 13 times the cosine of negative 70, and negative 13 times the sine of negative 70. Now before I plug this in my calculator, I'm going to do a little estimation of where I think that polar coordinate would be graphed. So if you think about where negative 70 degrees is, negative 70 degrees would be in quadrant 4, because you'd go this way. If the radius is negative 13, that means you would go back this direction in order to plot it. So the ordered pair that I get better be in quadrant 2. That means x better be negative and y better be positive. And what we're going to get is that x is about negative 4.5 and y is 12.2. So negative 4.5, 12.2 would certainly be in quadrant 2. Let's go down to C. First, I'm going to change negative 5 pi over 6 to degrees because I'm going to plug that into my calculator. So we're going to get negative 900 over 6, which is going to be negative 150. So where is negative 150? Well, if you graph it, negative 90, which means negative 150 must be over here somewhere. But since the radius is negative 2, you would go back the other direction in order to graph it. So the answer I get better be in quadrant 1. So x is negative 2 cosine of negative 150, and y is negative 2 sine of negative 150. So x is going to be 1.73, and y is going to be 1. And that would be a point in quadrant 1. D, already in degrees, and 270, where's 270? Well, 270 is the negative y-axis. And then if you plot a radius of 3, your dot is going to be here. As a matter of fact, I know exactly where it's going to be. It's going to be at 0, negative 3. So let's make sure that that's what we get when we plug this into the calculator. And that's what you're going to get. What does it mean for a point to be higher then another point. So I want you to think about the rectangular coordinate system. For points A and B, well, let me do it this way. I'm going to change that a little, put B right there. All right, for points A and B, which one's higher? Well, B is higher because it's in the positive y-axis as opposed to A that's in the negative y-axis. So even if these are at the same x value, I want you to notice that it's the y value that determines how high or low a point is. The x value determines how far the point is left or right. So in order to determine which point is higher, we want to know which one has the bigger y value. So all I'm going to do is I'm going to find the y value for each of these. So for point J, y is going to be r sine of 310. And for point K, it's going to be y equals 7.5 sine of 330. So for J, I'm going to get negative 3.45. And for K, I'm going to get negative 3.75. Which one of those is higher? Well, to be higher, since they're both negative, we have to determine which one's closer to zero. Well, this one's closer to 0, so that one will be higher. Let's do it again with part B. For J, y is 4.6 sine of 320, and K is going to be 3.9 sine of 295. And we want to know which one's going to have the either more positive, if they're positive, or the one that's closer to 0. So J is going to be negative 2.96. K is going to be negative 3.53. Well, this one is closer to 0. It's higher. So we talked about going from polar coordinates to rectangular coordinates. What if I want to go the other direction? What if I want to take rectangular coordinates and convert them to polar coordinates? So here's how it works. R is going to be the square root of x squared plus y squared. That is just the Pythagorean theorem. Remember the unit circle? And this was the radius of the circle, but it was also the hypotenuse of a right triangle, where x was the side of the triangle that was on the x-axis, and y was the other leg, and notice it's parallel to the y-axis. So if the Pythagorean theorem is a squared plus b squared equals c squared, and c is the hypotenuse, then another definition we had for the Pythagorean theorem was x squared plus y squared equals r squared. So what's r? The square root of x squared plus y squared. And how about theta? What's theta? Well, if x is positive, theta is going to be the inverse tangent of y over x. So look at the triangle. How do you find the tangent? It's opposite over adjacent, which is y over x. So you have to do the inverse tangent of that. However, if x is less than 0, so if x is negative, then it's going to be the inverse tangent of y over x, but you're going to add pi to it, or 180 degrees if you want to work in degrees. So let's go to example 3. This is x, this is y. So in order to find r, we're going to do the square root of x squared plus y squared. One of the most important things I'm going to tell you right now, make sure that you either remember that when you square a negative, you get a positive, or if you're going to plug this into your calculator verbatim, put those negatives in parentheses. Otherwise, the calculator is going to spit out the wrong answer. So, negative 8 squared is positive 64. Negative 12 squared is positive 144. So r is going to be the square root of 208. We're going to leave it as, well, I guess you don't have to do that. You can take the square root of 208. And it's going to be about 14.4. All right, so the radius is 14.4. Now we have to go find theta. Now, remember, in order to determine which formula you're using, you need to know if x is positive or negative. X is negative, so we're going to do the inverse tangent of y over x, but we're going to add 180 degrees to it. Remember, pi is the same as 180 degrees. So don't add pi, add 180. So in your calculator, inverse tangent of negative 12 over negative 8 should give you 56.3. And then when you add 180 to it, you're going to find out that the angle is at 236.3. So that means that the ordered pair, negative 8, negative 12, which is in quadrant 3, will be in the same location as 14.4, comma 236.3. Which makes sense because if you remember that these are the angles at the axes, 236.3 is going to be in quadrant 3, and then you go 14.4 circles out. All right, let's try it again. xy, r is going to be the square root of x squared plus y squared. 4 plus 8 is going to be the square root of 12, and the square root of 12 is about 3.5. I forgot to mention that the point 2, negative 4 is in quadrant 4. So if it's in quadrant 4, then I better get an angle in quadrant 4. All right, so since x is positive, we're just going to do the inverse tangent of y over x. So the inverse tangent of y over x is negative 63.4 degrees, which is definitely in quadrant 4 if you go in the negative direction. You do not have to change it to positive. You can just leave it as negative 63.4 degrees. I'm good with that. The last thing that we're going to talk about is rewriting equations. So what if you have a polar equation that we know how to graph, and we want to know what the rectangular equation is? So there are a couple different ways of doing this, depending on which kind of equation you have. So we know that if we have r squared, we can replace it with x squared plus y squared. We know that x can go in place of an r cosine theta, and we know that y can go in place of an r sine theta. So in this equation, if I multiply everything by r, I would get r squared is equal to 6r cosine theta. So I'm now going to replace r squared with x squared plus y squared. I'm not going to do anything to the 6, but the r cosine theta can be replaced with x. And this is the rectangular equation. Now don't write this down, but if you go and graph this, you're going to get the equation of a circle. Back in conics, when we studied conics, the equation of a circle was written like this. But sometimes you had to make that happen. And the way we did it was some process called completing the square. So I would subtract the 6x, and then I would make my own perfect square trinomial out of the x's. The way you would fill in that blank was you would divide the middle term by 2 and square it. 6 divided by 2 is 9. Sorry, it's 3, and 3 squared is 9, so this would be a 9. The reason I'm not doing anything to the y is because there's a y squared, but no y to the first. So I cannot complete the square. And then these were easily factored. And it turns out that this would be a circle whose center is at 3, 0, and the radius is 9. If you went back and you graphed this in polar coordinates, you would get a circle whose center was at 3, 0, and the radius would be 3. All right, I'm going to erase this part because you don't have to do that much work, but I wanted to show you what it was actually finding. So in part B, r is equal to negative 3, and I am looking for any of this stuff that I can replace. Well, there's no cosines or sines in this one. So instead of multiplying by r, I'm going to square both sides. basically does the same thing. It still makes the left-hand side r squared, but negative 3 times negative 3 is positive 9. Now I'm going to replace this with x squared plus y squared is equal to 9. That was a circle whose center is at the origin and whose radius is 3. And we talked about in the previous section that if you have a radius of negative 3, it just means you're graphing it the opposite direction, but it still ends up being a circle whose radius is 3. This direction is a little bit easier than going the other direction. What if I give you an equation in rectangular coordinates and ask you to write it in polar coordinates? We're only going to work with circles in this class. The other class, the honors class, they had to do conversions of some of those limesons and lemniscates and stuff. You don't have to do that much work because this is already going to be a little bit of work. So let's look at problem A, which is in rectangular coordinates. Let's change it to a polar equation. I'm still trying to do kind of the same thing here. I'm trying to do some replacing of stuff based off of what I have in the red graph. So I'm going to replace x with r cosine theta. And I'm going to replace y with r sine theta. And now we're going to do some multiplying out. So this, I'll do it the long way. Remember, you're multiplying it by itself. So you're going to FOIL. First, you're going to get r squared cosine squared minus 3r cosine theta minus 3r cosine theta plus 9. The middle terms are like terms, so they're going to combine into minus 6r cosine theta. All right, now I'm going to go back and I'm going to square this. So r sine theta times r sine theta is just going to be r squared sine squared. So this is plus r squared sine squared. And I think that's all I have to do, equals 9. All right, now I'm going to do some rewriting. I'm going to put these together at the front. And then I'm going to put the minus 6r cosine theta next. And this 9 here, if I subtract it from both sides, they end up canceling. The next thing that's going to happen is both of these share a common factor of r squared. And all of a sudden, I have something in parentheses that looks really familiar. Cosine squared plus sine squared was 1. And now I'm going to do r squared is equal to 6r cosine theta. I'm going to divide both sides by r, and I'm left with r is equal to 6 cosine theta. All right, we're going to do this again, but I'm going to put this on a new page. Okay, so first we're going to replace x with r cosine theta, but notice it's squared. And we're going to replace y with r sine theta. The next thing I'm going to do is square things. This is easy to square because it's just going to be r squared cosine squared. But this I'm going to have to do a little bit more work because I'm going to have to write it twice. And then I'm going to FOIL it. So I'm going to get r squared sine squared minus 1 r sine theta minus 1 r sine theta plus 1. The two terms in the middle are like terms, so I'm going to combine them. They're going to become minus 2 r sine theta. Now I'm going to add that r squared cosine squared again. And the same that I did in the last problem, I'm going to factor out an r squared from each of those two terms. I guess I forgot that it equals something, doesn't it? Equals 1. And then what's inside the parentheses here is 1. And if I subtract these ones, they end up canceling. And now I'm going to add this to the other side. And then I'm going to divide both sides by r. And I'm going to find out that r is 2 sine theta. The graph of the circle, what was it again? X squared plus y minus 1 squared equals 1, whose center is at 0, 1, and the radius is 1, will be the same graph that you would get if you graphed r equals 2 sine theta. And that's section 9.3 on polar and rectangular coordinates.